Hello everyone, I am honored to present our paper at the prestigious ISCV 2024 conference. Thanks to the organizing committee for gives us such an opportunity. Our paper ID is 287. The title of our paper is COVID-19 detection from CT scan images by using deep learning models. My name is Saida Sadia Alam. I am from the Department of Computer Science and Engineering of Metropolitan University, Sylhet, Bangladesh. The other authors of my paper is Kawsar Habib Munna and MD Mushtaq Shahriyar Rafee. Welcome to our presentation. Today I am pleased to take you through the roadmap of our research journey outlined in the table of contents for our presentation. We will begin with the introduction, where we will set the stage for our research in COVID-19 detection, highlighting its significance in the current landscape. Next, we will delve into the problem statement and conduct a literature review to explore existing methodologies, providing valuable context for our approach. Then we will share our objective and proposed methodology. We will detail this in the proposed methodology section, breaking down the steps of our innovation solution. To ensure the robustness of our method, we will evaluate it with different evaluation metrics. The result analysis will then present our findings, offering insights into the effectiveness of our approach. We will then shift focus to the real-world implications of our work, discussing how our research can directly impact clinical practice and public health initiatives. Lastly, we will conclude by looking ahead at the future work that lies before us, identifying potential avenues for further explanation and refinement in the clinical area. The table of contents serves as our roadmap, guiding us through each stage of our research journey. Today I am excited to talk about how deep learning is changing medical image analysis. At first, deep learning is making big advancements in analyzing medical images. Next, it is helping doctors quickly find problems in CT scan images, making diagnosis easier. And finally, deep learning is being used in important areas like identifying COVID-19 cases, improving how we manage diseases. Now I am going to share the problem statement. Nowadays, we address key challenges in combating COVID-19 through medical image analysis. Firstly, we must detect COVID-19 early from CT scan lung abnormalities when traditional methods fail. Next, we seek to automate COVID-19 classification, improving diagnostic accuracy efficiently. Lastly, our aim is accurate isolation of the virus within medical imaging data for precise treatment. Our objectives are clear. Firstly, we aim to accurately classify COVID-19 and non-COVID-19 cases from lung CT scan images. Next, we are working to automate the classification process, which will improve diagnostic precision. We are also utilizing various deep learning models on a lung CT scan images dataset to detect COVID-19 effectively. And finally, we are striving to introduce a new model that offers a superior accuracy and effectiveness. Now I am telling some background study of our research. The author Rafee and his team created a model CTNet which achieved accuracy of 82%. They experimented the VGG19 Inception V3, ResTnet 50, DanceNet 169, and VGG16 model. Uh, their VGG19 model achieved the accuracy of 94.52%. Then in 2021, the author Javadi Mugaddam and his team created a CNN model by using batch normalization and mist function, which pooling layer was combined of a pulling and squeeze excitation block layer, but their model increased performance with only a slight increase in total number of parameters and achieved accuracy of 99.03%. Um, the dataset we have used in our model contains 8,439 CT scan images of patients infected by COVID-19 and also suspicious ones with normal or non-COVID-19 results. The images are divided into two classes. One is COVID-19 and other is non-COVID-19. The images are in PNG format and a size of 512 by 512 pixels. Here is the sum images of our dataset. Let's talk about the important steps we take to prepare our data for analysis. Firstly, we resize our images to a standard size of 150 by 150 pixels. Next, we converted these images into batches of 32. These make it easier for our computers to handle lots of data at once and speeding up the process. When we load the images, we make sure to normalize the pixel values. This means we adjust them so they all fall between 0 and 1, which makes our calculation more accurate. But that's not all. We also use techniques like rotating, zooming, and flipping the images to create different versions. This helps our models learn better and make smarter predictions. These are some images before and after of pre-processing. So by taking these steps to pre-process our data, we are setting ourselves up for success in our research. Now I am going to show you the proposed methodology of our research. At first we have pre-processed our data and we rotate our data, feature extraction and reshaping. We have done this. Then we have split our data set into training, testing and validation. Then we train the model, the pre-trained model, EfficientNet before VGG19, VGG16, NASNet mobile and exception. Then we predicted and analyzed the result with different evaluation metrics. Now I am going to show you our customized CNN model, which we have proposed in the research. It is the diagram of our proposed architecture, which is a customized CNN architecture and suitable for image classification. It consists of a convolutional layers to extract features, pooling layers to reduce spatial dimensions, and fully connected layers for classification and dropout for regularization. The The shape of the input images are 150 by 150 pixels with 3 channels. Then we create a convolutional layer, which is convolutional layer 1 with 32 filters of size 3 by 3, and ReLU activation function is used. Then performs max pooling operation with a pool with a pool size of 2 by 2. After it, another convolutional layer with 64 filters of size 3 by 3 is created. After each convolutional layer, one max pooling operation has performed. It helps in reducing the spatial dimensions. Then again convolutional layer created with 128 filters of size 3 by 3. Then max pooling operation have done. Then created a dense layer with the flattened layers flatten the input. This converts the multi-dimensional input into one-dimensional array, which is required before passing to the next layers. Then creates a dense layer with 128 neurons and ReLU activation functions. With a rate of 0.45 dropout is a regularization technique to use to prevent overfitting by randomly dropping a fraction of neurons during training. Lastly, in the output layer, softmax activation function is used to output probabilities for each class. We have used these six models for the experiment in our methodology. The 5 models are pre-trained EfficientNet before VGG19, VGG16, NASNet mobile, and exception are the pre-trained model, and then we have proposed our customized model and used it for the experiment. Then we have evaluated the result of our models with different evaluation metrics. It is the confusion matrix. This confusion matrix is our proposed models, where we can see a misclassified images. It was a non-COVID-19 image, but our model predicted is COVID-19. These 3 confusion matrix and the misclassified images are the confusion matrix results of EfficientNet before VGG16 and VGG19 models. These 2 confusion matrix are the result of NASNet mobile and exception model. This is the ROC curve of our proposed new model, and this ROC curve is for the 5 pre-trained model. This is the accuracy graph of all experimented models. We can show that the validation accuracy of all models consistently improves with each epoch. To refine the pre-learned weights of the chosen CNN architecture, we use an ADAM optimizer with a low learning rate of 0.0001. We implement a specified patience factor of 5 epochs as a regularization strategy to avoid overfitting. This accuracy graph shows us the accuracy of all models. Then in the table, we can show the results of all models. We can show the accuracy, precision, Recall F1 score and AUC ROC score. Our model shows the exceptional performance with an accuracy of 99.96, precision of 99.97, recall score of 99.9, F1 score of 99.9, and AUC ROC score of 99.99. The other architecture performs impressively well, consistently achieving accuracy levels above 82%. Let's talk about how our research can make a difference in the real world. First, imagine a new application for doctors. It could help them analyze things faster and cheaper. Next, think about AI helping out with a diagnosis. This means doctor can spend more time with patients, giving them better care. Lastly, let's talk about COVID-19. If we can figure out exactly where it's affecting people, doctors can making sure they get the right treatment. So with our research, we are not just talking about sciences, we are talking about making healthcare better for everyone. In wrapping up, let's reflect on what we have learned. Firstly, our research has shown that CNN-based models have demonstrated exceptional efficiency in image classification. Secondly, the customer CNN model made for this study did really well with some misclassification result. As we wrap up, let's talk about what's next for our research. We can try fine-tuning our models and setting them to work even better. This could help us get more accurate results. Then we can add more different kinds of data to our collection. This might make our models stronger and more reliable. Here is some references of our paper. Thank you everyone for listening us.